Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. In this video, we are continuing with the ultimate guide in mathematics, and we're looking at the term 1 work, where the first topics that I want to cover to you are the sequences and series. And in the last lessons, we have looked already at the arithmetic sequence as well as the geometric sequence. Now I want us to continue to look now at the arithmetic series as well as the geometric series. So I'll encourage you, if this is your first time coming in contact with this lesson, ensure that you are subscribed. So what am I doing in this lesson? In this lesson, I'm going to prove or derive for you the arithmetic series. You are expected to know the proof of this arithmetic series. So we're saying the derivation of the arithmetic series formula. This is what we want to derive. So what I want to do is I will do the quicker version, not the quicker version as such. I'll go straight to the proof, and then after that, I will go through the details of why I was doing what I was doing. Okay, so just work with me. I'm going to just prove it straight away. Let's say you are in an exam, they say prove. So this is what I'm going to show you in a few minutes. And then after that, I justify or I explain why I was doing what I was doing. So we're proving this formula. Sn is equal to n over 2 2a plus n minus 1d, as well as Sn is equal to n over 2a plus l. Remember, n is the number of terms, a is the first term, and then n here, yes, being the number of terms, and then d in this case is the common difference. While in the last one, a is the first term and l is the last term, and n there being the number of terms. So now when you're talking about Sn, we're meaning the sum of terms. So when I'm proving this formula, let's write the formula again. Sn is equal to n over 2 2a plus n minus 1d, and we're proving the other one, which says n over 2a plus l. So these are the two formulas that we want to prove. All right, so look at this. I'm starting with Sn here to say, suppose I'm given Sn, and then Sn is a plus d. I need this closer because of my space, so let me make it closer so that I don't waste space. So it will be Sn, sum of terms, is equal to a plus d, let's put that in kind of brackets, plus a plus 2d, as I said, I will explain this later, plus, and then you can continue with this 1 2 3, it means it continues, and then plus, and then the last three times it's a plus n minus 3 d, and then let's put it like that, and then plus a plus n minus 2, here it's d, let's put it like that, and the last one is, I need to fit this all together, plus a plus n minus 1, it's fine, I don't have an option, let's do this, and it's n minus 1d there. All right, so this is what you're having. That is what, this is my Sn. So now if I take the last one and actually I'm rewriting this to say, if this was number 1, just to show you what I'm doing, if this was number 1, this was number 2, term 3, remember T1, T2, T3, and then T, that is n minus 3, the last 3, Tn minus 2,
and then t n minus 1, the last term. So if I start with this tn minus 1, what am I going to have? I'm going to have here again my Sn is equal to, so I'm going to write it now, it's a plus n minus 1 d. See that? I'm just starting from the last to the first, you see. So I'm going now in this direction. Okay, then the second one is plus a plus n minus 2, close there, it's d. That's what you'll be doing, plus, and then the next one is a plus n minus 3, and then d, and then plus, the other one is a plus 2d, and then you have got plus a plus d, and then you've got plus what? Let's erase this arrow now, and then we have plus a. Are you with me? Now if I then roll off here and I say we need to roll off here, and I say what do we need to do? We need to add in here. We say plus, you see. So if this was equation 1, let's do it here. If I said this was equation 1 and this was equation 2, so what I'm saying now, I'm saying equation here, equation 1 plus 2. What I'm simply saying is you add that. So when you are adding, you can put not real brackets, but you are adding. Let's leave it like that. So when you are adding, let me take the first one. For example, if I'm adding a, the first one, remember I'm adding these 2 here. I'm adding these 2. But remember the bracket. Look at the bracket. So I'm adding that with that. So I'm adding a plus n minus 1d. That's what I'm adding. But you can see that I just dropped the bracket. So if you're adding a is common there, which is 2a plus n minus 1 what d. See that? Let's say I want to add, let me do the same thing. Remember this was my t1, this is my t2, this is my t3, this is my t4, actually not t4, but there was 1 2 3 in here. I forgot something here to say dot, and then you say plus. I think I wanted to fit everything there. There is this dot before the a plus 2d. all right. So now let's say I focus on t3 and t3, these two. You see that I want to add. I just want to show you why I'm doing what I'm doing. Then I'm going to erase other stuff. Look at this. I'll be adding a plus 2d plus, and then t3 is a plus n minus 3 d. See that? But now I need to open this bracket so that d will multiply, so I will have a plus 2d plus a plus d times n, it's nd, minus d times 3 is minus 3d. Remember when you are opening the bracket, that then you collect like terms, a plus a, it's 2a, plus, look at this, d minus 3d. Okay, let me start with this, plus nd, which is this one, and then d minus 3d is minus d, so which is 2a plus, collect like terms, d is common, d n minus 1. But now if you look at this, it will be 2a plus, I'll start with n minus 1 and then I put d at the end. Now look, they are the same. You see, 2a plus n minus 1d, 2a plus n minus 1d. So it doesn't matter which ones you will be subtracting, you are all going to get the same thing, 2a plus n minus 1d. So as long as you are matching them. So for example, if I continue with the same way here, if I'm continuing with the way they are linked, so I will say when I'm adding, remember I'm adding Sn plus Sn, what do you get? Sn plus Sn, it's 2 of Sn on the other side is equal to, this one gave me a plus n minus 1, I mean not a, 2a plus n minus 1 d. It gave me 2a plus n minus 1 d, like that. That's what I got. Plus, if I add again my 2 and 2, if this was my T2, you add T2 and T2, you'll still get the same thing as 2a plus n minus 1, what? D. You see what's happening? You continue again, you add T3 and T3, you still get 2a plus n minus 1 d. As I said, I will explain other things later. And then do the same thing, you still get, when it continues, so it's the first 3, then you can say dot, 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 but still after this you'll get plus 2a plus n minus 1 d. I think that this continues. I don't have space, but you have to write it all the 3 times. 2a plus n minus 1 d. I think that just because of space. So this will continue like that. So what it means my 2Sn, you see that, is equal to, now I can just, you see, it's 2a plus n minus 1 d, 2a plus is repeating, right? So it means I'm multiplying because of this n, it's n times bracket 2a bracket n minus 1 d, because it's happening n times because of n. Remember, there is the dot, dot, dot. It's occurring up to n times. That's why it's sum of n. So now, when I have done this, it's almost done. What do? I need to make Sn the subject of the formula. Then I divide. Remember, I multiply by 2. So the opposite of multiplication, you divide by 2. I come here, I divide by 2. Then you do that to say Sn is equal to, you say n times, you can drop that times, then it becomes n 2a plus n minus 1 d. Okay, good. Brackets all over 2. But this is the same as someone who's saying, you can take this to say n over 2, still mean the same thing, and then you write it like this: 2a plus n minus 1 d. It's the same because this is over 1, so it's 2 times 1. Are you with me? So this then becomes this particular formula here. Sn is equal to 2a plus n minus 1 d. And then at the same time now you want to prove the other one. Now look at this, the second formula. If I continue and say Sn is equal to n over 2 2a plus, I want to remind you, remember what is Tn? Tn from the previous lesson is a plus n minus 1 d. That is the nth term. So now I can rewrite actually this part inside here, this one. What is 2a? 2a is same as saying a plus a plus a is 2a plus bracket n minus 1 d. So now look at this. If I cut it here and I cut it here, look at this, a plus n minus 1 d. This is my what? This is my Tn. You see that? So if I want to find any term, let's say I want to find my last term will be a plus n minus 1 d. Then Sn becomes n over 2, and then it's what? A plus the last term. So guys, this is the proof of these two formulas. The first one, which is that one, and the second one, which is that one. Now, as I say to you, in a quick one, why I was doing what I was doing. If, for example, I give you a sequence, let's look at this sequence. If I say you have got, let's say, some, by the way, the difference between a sequence and a series, a sequence is this. If I say 2, 5, 8, so it's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. If I give you that. Now, this is a sequence. Now a series, what is a series? A series is when you start to add. Now when you say Sn is equal to 2 plus 5 plus 8 plus 11 plus 14 plus 17. Now this is a series. Alright, now as you can see in this series, you start from the sequence. What is the common difference is, remember, it's T1, T2, T3, T4, T5, T6. So you can see that T2 minus T1 is 3. It's 3. 8 minus 11, it's 3. You see that this is what? Remember, this becomes the common difference. And A becomes the what? The first term. So the first term is what? It's 2. The common difference is what? The common difference is 3. So if we can follow what we did previously, we said this is what I'm given. Now I can also write my new Sn. I say you start from the end, you start this direction. So when you start this direction, you will have 17 plus 14 plus 11 plus 8 plus 5 plus 2. Remember what we did? We did in this scenario. That's what we did. I started from this. For number 2, I started from the end, so if you still remember what I was doing. So when I do that, look at this. If I add this, if I say plus and then I add this, it would be 2 Sn, because it's Sn plus Sn. Then 17 plus 2, it's 19. Now 14 plus 5, it's 19. You see what's happening? 11 plus 8, it's 19. This is 19. This is 19. This is 19. Do you see what's happening here? Then I can say 2Sn is equal to, now in the previous one I said n times. Remember, I said n times this thing that was repeating. It was similar here. It's like you're saying 19, 19, 19, dot, dot, 19. Then we said n times. But here I know my number of terms. How many are there? There are 6. So it will be 6 times 19. Then I divide by 2. I divide by 2. Then my sum of these terms, if I was adding them, you divide there is 3. And then it will be 6, 19 times 3, 9, 18, 27, 7 carried 2. It will be 50 what? I think it will be 57, but we can quickly check that. So this is in a way the first part that you need to I'm trying to explain now how this went about. 6 times 3 over 2 equal to what? 57. Even if I add this, you can try with your calculator. Can you quickly add them? Which is 2 plus 5 plus 8 plus 11 and then plus 14 plus 17. What am I getting? You see, I'm getting 57. So it means it's working. So now what I want you to do whenever you are proving it now, as I'm explaining, remember the first one was A, and then the second one was A plus D, the third one was A plus 2D. Where are you getting this? You're getting it from the formula Tn is equal to A plus n minus 1 D. Remember, so we're saying when n is 1 for T1, because this is T1, this is T2, this is T3, the first 3. So T1 is A plus, there where there is n is 1 minus 1 D. So 1 minus 1 it's 0. So it will be A plus 0 D. This goes, that's why we got A. What about T2? T2 is equal to A plus my n now is 2 minus 1 D. So which is equal to A plus 2 minus 1, it's 1 D, which is same as D. Then we got that one. What about T3? T3 is equal to A plus 3 minus 1 D, which is A plus 3 minus 1, it's 2D. So you see, that's where we got this. Now the last two, if the last 3, remember the last 3 that I showed you, the last 3, my T3, my T, actually my last T t last was a plus n minus 1 d. This is where you need to be sensitive. And the following one before that is t minus n minus 1. It is a plus n minus 2 d. And that's the following one was a plus n minus 3 d. Now if I can bring them to you, these ones, a plus n minus 3, a plus n minus 2, and a plus n minus 1. Actually, now look at this. It is actually tn minus 2. I want you to be sensitive now. Where is this coming from? If I say to you, remember this is tn minus 1, it is coming from, if I take it directly again from this formula, our tn is equal to a plus n minus 1 d. If I say what is the previous one, if you go just before this one, it will be n minus 1. Are you with me? Just like here, look at this. You had t6. Now if I want to go to t5, this is t6. To go to t5, it will be t6 minus 1. To go to t4, it will be t6 minus 2. So the last three, you see it's 6 minus 1, 6 minus 2. So even here also, the last three, so there is an error here I made that needs correction. This is t minus 1, tn minus 1, this is tn minus 2. That's the right one. The first one is tn minus 1, the other one is tn minus, this one is tn. That's why I think the error was, this is tn, this one. The last one is tn, then tn minus 1, tn minus 2. Okay, so even here, if I say tn minus 1 is equal to a plus, where there is n, I put n minus 1. See that? That's what I put. So it's n minus 1. This is what I put in here. And then there is minus 1 again. And then you put d. Then it's a plus minus 1 minus 1. It's n minus 2 d. I think that. Then this is why we got this. Then for tn minus 2, you do the same thing. It's a plus n minus 2 minus 1. Because now where there is n, I put n minus 2 minus 1 d, which is a plus n minus 3 d. Alright, just to say, when you are proving it and you are getting confused, this is what you need to do. You say, okay, I know my first three terms. It's a plus d plus a plus 2d. This one I think you can flow. This is t1, t2, and t3. But the challenging one is ... when you find the last three. Now the last three, this is what you do. You say, okay, I know my general formula is tn is a plus n minus 1 d. Are you with me? Then the other one, you're going to say tn, the previous one, which you just put minus 1 there, it's a plus n minus 2 d. See where you're changing? And then the other one following it's a plus n minus 3 d. So this is your last. And then you go backwards, Then after that, it's a matter of now following the steps that I showed you in that part. So guys, proving this is very, very important for your curriculum. You are expected to know it, and they might ask you in your final exam. So I hope this was making sense. In the next lesson, I'm then going to show you how to work about this arithmetic series. You see, there are questions I want to do quickly so that you can get familiar in using this arithmetic series. It's a very important part. You see, there are questions there. I give you the summation so that you can understand what is the summation and how do you go about this. Join me in the next lesson. Remember, subscribe to benefit from these lessons. We have come to the end of our lesson. Thank you.